Hello everyone. This is the lab tutorial for the free fall motion online. This will be the second experiment that, no, free number two, that you will do online using a simulator, or in this lab as well, you could actually use the exploration physics. If you have installed this has a few simulators in here. If you go to motion, it will give you a few that we're going to be using or that you could use as an alternative for the online simulators. For example, force tables, projectile motion, the incline plane, even some of the spring and pendulum. I don't think we're doing this with you guys, but as a demonstration, you can always take a look and see what they have. And normally, it's just what you find online. They just show you a simulation with a graph, give you some values like period, the displacement of a mass in a simple harmonic motion, for example, right? So the idea with this software, if you can install it, is that you don't have to go online to look for a simulator. For example, for the free fall, you can just go here and basically you can just run the simulation. If I want to drop a mass, I click on play, and what happens is that, so we don't want that. We don't want bouncing. So here, and we let it go, and that happens. So we have an initial height. We have the mass and radius of the ball, right? So we can do the experiment using this. However, what you see here is that the maximum height is 20. You can change that in here up until 100. Now, let's take a look at the lab manual and see what the instructions are. So you have a table of data, and you will use the simulator or exploration physics to drop a mass, drop a ball. You will find, or you will use different heights to drop the ball and measure the time with the online stopwatch, or you will use the timer that you are giving in the software. I would recommend using the online stopwatch or like your mobile phone, just so you can see or you have a feeling of what you will be doing in a lab. Because in a lab, you will normally do something like that. And it's a way to introduce some level of uncertainty and discrepancy. There's nothing wrong with that. At the end of the day, this lab has the objective of verifying the acceleration due to gravity. And you're going to do that by plotting the distance versus time average square. So let's explain this table. You have 6 values of height, we call it D. And then you have 3 different values of time. So for the same height, you're going to do 3 different trials. You will find the average time, and then you will square it. Because what you are going to learn in the lecture is that when you plot the distance, or in this case, the height, traveled by a mass, drop towards the ground as a function of time square, you will get a straight line. And the slope will effectively give you a factor that you can use to find the acceleration of gravity. Okay? So I think what I'm going to do is I'm going to show you, not using the average, but I'm just going to take the data for a few values of height, and then I'm going to show you how to do the graph. Because I have the feeling that that's the tricky part on this experiment for many of you. How to do the graph in Excel. Many of you use Google spreadsheets, and that's fine. If you want to use that, it's fine, but keep in mind that Excel is more accurate. And at the end of the day, you guys, even though you might not go into science or engineering, you want to know, you want to learn how to use Excel. It's a very practical tool for statistics, for math, for data, for plotting. So let's take a look at that, all right? So let's suppose you use a simulator. So the simulator is here. You can reset it anytime you want, and you can see that you can change the values of height. If you drop it, you can use a stopwatch, but I'm going to use the time. Now they give you the velocity versus time graph and the distance versus time. The distance versus time is actually a parabola. So we can use that, but let's linearize it by doing distance versus time squared. That will give you a line, as you will see in a bit. So let's use some values of height. Let's start with, here you can go to 130. So let's start with 120 and then let's do a few values. Remember, you have access to Excel via Union College or any college website that will have free access for you guys. Okay, so the way you do this is you can put distance in meters, and here you will do time square or t square, let's put it like this, in seconds square. Let's make this bigger. I don't know how you're gonna see it in the video. Okay, so let's just start with 130, so we drop it. Oh, what happened there? 130 or 120. We drop it and then we measure the time, 4.9, so you don't have to do this. Oh, this 4.9 is gone. You have to do free trials and then do the time, the average time square. I'm just doing it so I can show you this quickly. Oops. Let's go to 90. It's 4.3. So here you can do equals 4.3 times 4.3 because it's the time square. That. We set it. We make this now at 70. That's 3.8. Let's do one more. Just for the sake of it. 50. 3.2. There it is. So these are data I gathered from the simulator. Remember, I'm going to emphasize this again. In the lab, you will do free trials for each height. And then you will find the average and then you square the average. I'm doing it like that just to save time. Now, that's not the way you want to graph it. So this has to be in the x-axis. So this will go here. X, Y. So you highlight your numerical values. You go to insert, you go to charts, and you click the scatter plot. And as you can see, you are getting a linear trend. Make this big. In the graph, you're expected to have the chart title, the axis titles. So for example, here you will put distance. versus time square for a free falling object. Here you have distance in meters. And here you have t squared in seconds square. That's almost there. How do you find the slope of a line? You do right click and then you add a trend line. It will give you this option, format trend line. You leave it in linear, you display the equation on chart, and that's it. So there you are. Now, how do I calculate my value of gravity? So the value of gravity will be the slope. What's the slope in this line? 5.0825. Now, in 2 sig figs, it will be 5.1. You have 2 sig figs here, or 1 sig fig here, 4 here. So, well, we have 2 decimal places. Let's just use 5.08. So 5.08 times 2. That will be your slope. That will be your value of gravity. Let's see what we get. 10.16 meters per second square. Now, why times 2? Because I hope that you guys will be introduced to the equations of motion. And then in the equations of motions, the y value, the distance, the height, is initial velocity times time, plus or minus 1/2 gravity times square. So the factor of t squared is a half of gravity. So we multiply by 2 the slope, and that will give us the value. And it's not that bad, right? Because the experimental gravity, the accepted value, sorry, is 9.81 or 9.80 meters per second square. So you will do a percentage difference. All right. For the percentage difference, you will do equals apps as the absolute value of the accepted minus the experimental, all divided by the accepted. And then I multiply this value by 100%, and I get 3.67, right? 3.67% percentage difference. So that's what you have to do. I really think that you guys should go back and forth in this video to understand how to do the graph and the data analysis. It's not bad. That's why I try to make the experiment easy and quickly. So you actually spend your time doing your calculations. Remember that you can send me an email and you can collaborate with one another. In case you have questions about this lab, but it's quite straightforward to gather the data. All right. If you have any mathematical questions about the graph or even the physics behind this experiment, please send me an email so we can probably do an exchange or do some office hours, right? Some meetups. Until next time, guys, have a good rest of your day.